Hello and welcome back to the Age of Gaming. In this video, I'm going to go over the experiment and the program in Chapter 6 of Programming a Microcomputer 6502, which is actually a combination lock of sorts. We're using the same circuit as I built before in the last video, except that I've exchanged my dip switches for these really fancy 8-bit push buttons. However, there's a difference in these push buttons and the switches, and that is that when these are not being pushed, they're all highs. So I'm getting all highs on my input right now. You can see that here at 1700, they're all high, and if I push something, it goes low. So what I have to do in my program is an XOR. After you load A with 1700, which is your port A inputs, then I immediately do a XOR to convert this FF back down to 00, or this 01, or this FE down to a 01, and so on and so forth there. So anyhow, let's take a look at how the program works here. Address 0200. It works a lot better than the dip switches because it's easier to press these buttons down than to try to move a dip switch. So I'm going to press go, and the first code is a 3, so I'm going to hold these two first buttons down. You see the light went, the B light went green. And then the next one is a 4, and the last one is an 8. It's funny too, this book, the Programming of a Microcomputer 6502, this graphic on the front of the book itself is basically from this program. You got the A LED that, always goes red if you hit a wrong number. You got B if you get the first code right, C if you get the second code right, and D if you get the third code right. So that's kind of just interesting. Let me do this one more time. You got B, C, and D. Yay! So it's working, and this also demonstrates that you can use your alligator clip instead of a ribbon cable, because when I'm using these 8-bit push buttons, it takes up a lot of board space. So it's easier to use an alligator clip to go out to everything. Anyhow, let's take a look at the program up on the screen. Okay, let's go over the code that they have for this little project. They start off with this load X with FF and store that into the stack. That seems like useless because we're not using the stack at all. So I just put a bunch of EAs or no-ops in there and went on to the next one. I leave it open just in case I do need it. That's why I put the no-ops in there, because they'll just ignore that and keep running the program. So the first one is load A with 00, and then store A at 1701, which is our port A data directional register. So now we just set up our port A as all inputs. Now this next little group of commands is LDA 00, store that in our port A data register. Well, you can't store any data in that register if it's set up as an input. It only gets its data from the external inputs that we have connected to the pins. So you can't just write information into port A right now. So I EA'd all that too. The next step was load A with FF and store that at 1703, which is our port B data directional register. Now you just set up port B to be all outputs. So that part is all good. Those and those, that all looks good. Now we start the main part of the program. The first thing they do is, or they LDY or load Y with 00. And then they jump down here to the subroutine at 230. Well, 230 automatically lights up something. So first thing it does is it looks at 206 plus Y, so it's doing an LDA with an index of Y. So you go down here to 260, and the index of Y right now is 0. So you go down here to 260, and here's our 0. So you're going to get a 0, 1, so the first LED is going to get lit up. Okay, so that's lit up. Then it goes into loading the port A into A again. I have to do an XOR here because of my push buttons so that we have the correct numbers. And branch if not equal, back up here to clear. So if it's not 0, it's going to keep branching up here. So once you let go of the button, it's going to be 0 thanks to our XOR. Otherwise it would be FF. Then what do we do? Oh, like I said, we branch. If not, then we'll load the inputs at port A again. Again, I have to XOR that again. And then this time we'll branch back up if it is equal 0. That means if nothing's changed, it'll just keep staying right here until you actually press a button. Once you press a button, it's not going to be 0 anymore, so it's not going to branch anymore back up here. It's going to fall through. And here's where we just start our timer. This whole section right here down to here is just timer, so really nothing amazing to go over, and a delay timer there. You can look it over if you want to. And then it comes down here to loading the A port back into the A register. Of course, I have to XOR it again to get the right information. And then what it does is it compares. It does compare with an index of Y. So what it's going to compare is here at 0270. So you go here to 0270, and it's going to compare to see if it's one of these. If it is one of these, specifically, let's say 03. This is actually your code here. Let's say it's 03. Then it's going to branch, if not equal to anything, it's going to branch back up to start, and the red's going to be back on. But if it is equal to something, it's going to return to where it left here. And then it's going to go through this next one, which is LDI1 or LDY1. And again, come down here, and it's going to light up that first green light because it's going to do an LDA Y, and right now Y is 1 at 260. So you go down here to 260, and 1 is the 02 light, or the first green LED. And again, it's going to come right back down here and wait for that button to be unpressed and go back to 0, and then wait for another button to be pressed to decide whether it's going to jump back to start and turn this thing red, or it's going to find something here at combo, like the next code, and then jump back up here to the next subroutine, which is LDY2. So that's pretty much it in a nutshell. I mean, you can look this over. Maybe you can see some other things in there that are interesting, but it's actually pretty simple. Again, it's kind of hard to do with the dip switches because it's hard to hold flip those switches, but it is possible to do it, and I have done it. So whether you use, I put my notes in here, like this XOR is only needed if you're using like the push button array like I'm using, not needed for dip switches. Use no ops if you're using dip switches. So it tells you right here what to do. And like I said, these were unnecessary. And oh, here's something real important. These, you see where I do branches here? I always check before I run the program. I'll do single steps, like right here. I'll load this, go through that, and see if this branches to back up here where it's supposed to. And I do that for every one. I make sure the branch goes where it's supposed to go by single stepping through it before I start a program, before I go into actual run mode of a program. And I make them green once I've tested them all out. Before I test them out, I always have them like some other color. But anyhow, that's it. Hope you learned something from this. It was a lot of fun. Again, this is Programming a Microcomputer 6502 by Caxton Foster. Anyhow, have a great day.